So this is 5.6 problem set in trigonometry, half angle identities, and I have number 21 on there just to kind of go over with you. This is from the solution manual, so we'll just kind of go over what they've already written, save you from having to read my stuff. It says find each of the following. So what we're looking for here is we're looking for the tangent of pi over 2, or theta over 2, given that the sine of theta is 3/5, and we are in the second quadrant, 90 degrees to 180 degrees. So that tells you where theta is. So you're looking for tangent. And if you remember, tangent, we have to know cosine and sine, because we're given, cosine, or sine right here of 3/5. And if you remember, tangent is sine over cosine. And I am not sure why they did this the way they did, because what I would do is, we know we're in quadrant number 2 because of this here. So if I draw a triangle here, and I know my sine is 3/5, that's opposite over hypotenuse. And remember, a few videos ago I said that if we have that as a 4. You can use Pythagorean to find that as a 4. And so the cosine of theta is going to be adjacent over hypotenuse, and the adjacent is going to be negative right there. So we get cosine of theta equals -4/5, which is what they got there after they did all that work. So anyway, you can use Pythagorean, you can use drawing a triangle like I did, or you can do whatever in the world they did up here, but that seems like that's kind of ridiculous. Alright, so at this point they're taking one of their half angle identities from page 222, and looks like they're using the middle one there, and they're just putting 3/5 over 1 plus -4/5, which they got there, and you just do the algebra here until you get 3 for an answer. Okay, so 33 to 44, they say use an identity to write each expression as a single trig function. Look at example 4 that we did in the lecture, and there's 39, 41, and 43 from the solution manual. Notice what we've got here. The original problem right here, number 39, and then we're going to our half angle identities again on page 222, and we're using 1 plus cosine of 18x over 2. We're using that first one, top one on the left, and that equals the cosine of the angle, which in this case the angle is right here, 18x over 2. So we're just reducing 18x over 2 down to 9x and leaving the cosine. So we really didn't do anything. We're given the formula, and that's cosine of whatever angle that is over 2. And that's what we've got there. Same with 41 and 43 there. Only on 43, the angle is x over 4, so that's what goes there. Take that 2 over 1, invert and multiply, and you get x over 4 times 1/2, which is going to be x over 8 then for your cosine. So that's the 33 to 44 problems. And 49 to 56 is talking about verifying that each equation is an identity, and looking at example number 5 for some help. Let's look at number 51. Sine squared of x over 2 equals the tangent of x minus sine of x all over 2 tangent x. So what we're trying to do is prove that this is true. Verify that that's an identity. So we're working with the left side, and notice what they did here. They took the sine squared of x over 2 and wrote an identity here that equals plus or minus this whole thing. And then, because we have this squared and this squared, we're going to take the square root off. So this here just equals 1 minus cosine squared of x. And then we work on the right side. So remember, we changed this to 1 minus cosine of x over 2. Now we're going to work on this side and see if we can make it into the same thing. So we took this thing here, which is right here, and we wrote it as sine over cosine, because tangent equals sine over cosine minus sine. and we change this to sine over cosine, because remember, one of the things it said to do is do everything you can to make everything sines or cosines. So we're getting rid of the tangents. So what they did here is just, they didn't really do anything here except find common denominators. Now, so they multiplied both of these by cosine of x because those are on the bottom there. They skipped a couple steps here. They multiplied this whole thing by cosine of x in order to get rid of the denominator here. So then they've got sine squared of x minus cosine of x sine of x. So they multiplied the whole thing by cosine of x in order to cancel this. So when they multiplied this by the cosine of x, the denominator disappeared. When they multiplied this by the cosine of x, it stayed next to the sign because of that minus. This was basically distributed, that cosine, so it canceled with that, but it stayed when we multiplied it there. So that's why you have them both there. Alright, we did the same thing down here on the bottom. We multiplied everything by the cosine of x in order to get rid of that one. And we're left with 2 sine of x, which is what they have right there. Alright, so what they did here is you've got a sine here and a sine here. They factored the sine of x out. And remember, this is one of the hard things that people do. They're like, oh, I'm going to factor the sine out and this will go away. No, it doesn't. There's always a 1 there because when you distribute this back, you have to be able to get the sine back. And if that disappeared completely, you wouldn't have a sine times a first term to give you this sine back. So remember, you've got to leave that 1 there. Minus cosine of x over 2 sine of x. And my sines cancel right here and right here. And I'm left with 1 minus the cosine of x over 2, which is what I got up there. So I just verified that that statement was true. And that's what they're doing here. You know, and really, there's a lot of things that are going to be kind of confusing as you're reading through here, and you're like, well, why did they do this, or how did they do that? Just get a handle on kind of what's going on here. I'm not real concerned that you're really, really good at this because they kind of rush you through this. They don't give you a chance to get really, really good at this. So I'm just trying to make you familiar with it so that you're like, okay, seen this done before, don't really understand exactly how it works, but at least I'm following it somewhat. That's what I'm looking for here. So that's the problem set in lesson 5.6.